So now we're being asked to outline the mechanism for the reaction between compound Q and HBr using curved arrows to show the movement of electrons, right? And so whenever we're asked to outline a mechanism, we have to know which mechanism we're going to be outlining, right? So compound Q, we already ascertained or we determined that that's an alkene, right? And here's a HBr that's being added. So to compound Q, we know it's an alkene. And so alkenes and HBr react via which mechanism? It's going to be electrophilic addition. Okay? Electrophilic addition. That's the mechanism by which alkenes react, right? And so we're going to just set that up now to show that. So what's my alkene again? I'm going to draw the butene form of it. And so I'm going to draw this one. So it's going to be C double bond C, and then one, and then another. And then we're going to just populate our H's there for completeness, right? So let's put our H, 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 and H. So remember, it was C4, H8. All right, so I just drew this form, which is what we said, it was butene, okay? All right, so let's look at this molecule. When we look at this molecule, what do we notice? We notice that it's an asymmetric alkene. If I were to like split it, if I were to split the molecule along the double bond, they're different halves. I would get different portions, right? They're not the same. So that's an asymmetric alkene. So that's important to notice. Whenever we're given any alkenes or we're working with alkenes, we have to see if it's asymmetric or symmetric. So if we split the double bond, is it the same on both sides or is it not? So because this is not the same on both sides, then it is an asymmetric alkene. All right, so because it's asymmetric then, so we're gonna have to apply Markovnikov's rule because it's an asymmetrical alkene, so keep that in mind. So let's get into the mechanism now. We have our asymmetric alkene here, it's butene, and that's gonna be reacting with HBr. So I'm gonna put my HBr, I'm gonna put the H in pink, and then I'm gonna put the Br in orange, okay? All right, and then there's a bond that connects them. We know that, right? And there's a shared pair of electrons between both of them. Okay, so that's our HBr molecule. Now, our HBr molecule, in and of itself, is what we call a polar molecule, right? It has a dipole in it, where this part is partially positively charged, the H, and then the bromine, being more electronegative, will have a partial negative charge to it, right? And so what's gonna happen when this is in solution and the alkene, the alkene sees it, right? This electron-rich portion, the carbon-carbon double bond, is very electron-rich. It has 4 electrons in here. When those electrons see this positive end of the HBr, they're gonna latch onto it. So they're gonna grab onto the hydrogen and say, come and join us and be a part of our molecule, okay? So the double bond is gonna grab the H plus to become a part of it, and the H plus will have no choice but to give away both of those shared electrons to the bromine, okay? And so what happens here then is that we end up with this intermediate structure. So let's draw what our intermediate will be now. Now, the H is going to end up being here. And where's the H going to go, right? The H could have gone here or here, but based on Markovnikov's rule, the H is going to go where there are already more hydrogens, right? You see how there are 2 hydrogens here, but there's only one on this one, and then an ethyl substituent? Yes. The H is going to want to go where there are already other H's, like here where there are 2. So we're going to put the H on that carbon, right? So that's where we're going to put it based on Markovnikov's rule. And so we're going to put the H here. right? It's going to get incorporated there. And then what's going to happen now is that this carbon is going to become a carbocation because in so doing, right, I got rid of the double bond. So now this is devoid of a bond. And so now all it has are 3 bonds around it. And so it forms a carbocation. And then the rest of the molecule will be the same for now, right? So put the H here. All right, so the rest of the molecule is the same. We've added in the hydrogen, we have our carbocation. Now down here, when the bromine took away both of these electrons from the hydrogen, right, what left or what remained or what was formed rather was a bromide ion, right? And that bromide ion then is negatively charged. That's gonna be able to donate these 2 electrons that it has, right, to that positive carbocation and form a bond there. And so when that happens, we're going to end up with our final molecule. So here's our final molecule now. It's going to now be CH, H. So I'm writing all the original parts that remain of this molecule, putting in those first. All right, and then we're going to put in whatever got added in. So we're going to put the bromine now. Actually, let me keep my colors consistent. So we're putting in the bromine now. So the bromine went and attached there where the carbocation was. And then the hydrogen, of course, from earlier, we said would have latched on to where there were already more carbons. And so that's our molecule, right? That's the new compound that would be formed. And what do we call this compound? We can name it. Let's name it for completeness sake. If we start counting from here, so that the bromo is on the lowest numbered carbon. Let's number these carbons. Let's number them. This would have been my carbon 1. This is my carbon 2. This is my carbon 3. And this is my carbon 4. So when I name that, I'm going to count 1, 2. That's where my bromo is. So that would have been 2 bromo. And what is my longest chain? 1, 2, 3, 4. So that would be what? 2 bromo butane. Okay. And so that's all that there is that we had to do in the way of writing out this mechanism. So remember, if we're working with an asymmetric alkene, you're going to have to apply Markovnikov's rule, and then we go from there. Okay? And so we're going to move on to the other part of this question now. So let's just clear everything and go ahead. And it says now, state the type of mechanism outlined in C part 4. So in C part 4, what we had outlined was the electrophilic addition mechanism. Okay? And so with that, we've come to the end of this question. Definitely give this video a like, subscribe to the channel, and if you look on your left here, you'll see the next video up. And if you look on the right here, you'll find our Module 1 playlist with tons of interesting content that will be helpful in getting you prepared for your exam. So thanks for watching, and we'll see you in our next video.